Hi there, my name is Jeroen Boeien and I'm a machine learning engineer at Faction. And in this video, I'll introduce you to the concepts of digital twins and reinforcement learning. Now, if you've ever seen the movie The Matrix, you may remember that at some point, Neo is uploaded into a simulation where he learns Kung Fu fighting. Now, for Neo, there's two advantages to learn how to fight in a simulation. The first thing is that his real body remains unharmed. The second thing is that because the simulation runs on a super fast computer, he can actually get a lot of exercise done in little time in real life. So he can learn a skill that would normally take a decade to master in an hour or so. Wouldn't it be cool if we could apply that approach to a real-world system? Turns out it's perfectly possible. All you need is two components. The first one is the simulation. That is a digital twin of a real-world system. And that allows you to try out different behaviors and gives you a realistic outcome. In the movie, that would be the Kung Fu gym and the opponent that Neo is fighting against. The second component you need is the agent. In the movie, that would be Neo. Now, the agent goes into the simulation and tries out different things that lead to a certain outcome. Now, of course, you want this agent to learn. And to make it better at what it does, you will actually look at the decisions that it makes. And when it makes a good decision that leads to a good outcome, you will reward that decision. You will reinforce the behavior that the agent showed. That's why it's called reinforcement learning. Now, once the agent is really good at optimizing the outcome in the simulation, you can transfer that agent to the real-world system and have it optimize that as well. The hard part here is building the digital twin. Building a system that really behaves like a real-world complex system is really hard. So say you want to optimize an industrial production process, then you need a lot of data on how that process behaves. You need a lot of inputs that lead to a certain outcome of the process. Now, because of the complexity and the size of this data, we typically use deep neural networks at the heart of our digital twins. Now, if you have this kind of data and a process that needs optimization, the machine learning engineers and sensor data experts at Faction would love to help you optimize that process. So feel free to contact us at our website www.faction.com.